The Earth, with its many dynamic and complex cycles which facilitate the continuation and proliferation of life, providing for the needs of life that which rely on it to continue. But what happens when the life it sustains becomes the cause of its own demise? Greetings, one and all, and today we aim to describe to you the story of one such cycle, the phosphorus cycle. By answering the what, the why, the who, and the how, we will show you the crucial importance of this element and its cycle.
To start off, what is the phosphorus cycle? The natural ecosystem is self-sustaining, and thousands of individuals, biological and geological systems work together with each step of the chain efficiently, utilizing and passing the phosphorus to the members of the next step in the cycle. And with that, phosphorus cycle originates from weathering, from natural deposits, where weathering causes the release of phosphorus into the soil. This is tied to the sedimentary cycle, and this process involves the gradual release of phosphorus into the environment from natural deposits through natural weathering, which then is taken up by several organisms, whom which then return any absorbed phosphorus back into the environment through the expulsion of waste or the organism's eventual decomposition as a whole after its death through bacterial and fungal decomposers, and hereby completing the cycle and enabling the repetition of this process.
Now, why do we need to know this? In what way does preserving this cycle benefit us or the environment? First and foremost, phosphorus is an essential nutrient for life. This nutrient is a limiting factor for plant growth, meaning its availability directly impacts plant health and productivity. When readily available, phosphorus fuels photosynthesis, producing robust root systems, abundant foliage, and increase in flower and fruit production, which forms the base of the food chain. For soil microbes, phosphorus is essential for growth and activity. These organisms are crucial in decomposition, nutrient cycling, and plant health, boosting soil fertility and overall ecosystem productivity. In humans, however, adequate phosphorus intake is crucial for bone health, maintaining strong teeth, and preventing osteoporosis. It also plays a vital role in energy production, cell signaling, and muscle function.
Hi. Secondly, phosphorus maintains ecosystem balance. Just as was mentioned earlier, this cycle provides these necessary nutrients for plant photosynthesis, combined with the natural speed of the sedimentary cycle. The cycle's slow rate helps stabilize the ecosystem against the oversaturation of life within an ecosystem. Phosphorus locked in rocks acts as a reservoir, slowly releasing the element and limiting the speed of species proliferation. Next up, phosphorus also helps with the fight against climate change. Phosphorus, phosphorus-rich sediments stored on the ocean floor can sequester carbon dioxide, potentially mitigation the effects of the rising atmospheric CO2 level.
Now, who is responsible for the changes and influences made on the system? Which species affect the greatest degree of change for the phosphorus cycle? It should come as no surprise that we humans are the greatest disruptors of the natural order. Human actions, such as mining, involve the artificial extraction of phosphorus from natural deposits, depleting while releasing these reserves out into nature. With the rising demand for crops, farmers use phosphorus-containing fertilizer to speed up plant growth, which effectively puts a great imbalance on the local ecosystem. In addition, leaching of such an excess of phosphorus into a local body of water triggers the occurrence of an event known as eutrophication, wherein an excess of present nutrients accelerates organism reproduction, oversaturating the local ecosystem with a population larger than it can support, depleting resources until its eventual natural regulation through mass death.
Now the question is, how can we help? With our impact on this cycle, as mentioned previously in mind, it is our responsibility to manage, minimize, and mitigate our impact on the environment. With this, the following are some ways we can and should help. One way could be through phosphate management in agriculture. Further refining the process of phosphate used in agriculture, farmers can reduce the risk of phosphorus runoff into water bodies by correctly measuring and applying phosphorus-containing fertilizer depending on crop-specific demands. In addition, use of synthetic fertilizer with more sustainable options would also reduce our overall impact on the environment.
Next, another way could be through innovation and research. As mentioned earlier, development of new and more sustainable fertilizers would truly cut down the amount of phosphorus released into the environment. Furthermore, innovation could also bring us ways of reducing, recapturing, and or preventing the leaching of these compounds away from the controlled environment and into the natural ecosystem, either through developing advanced filtration systems, treatment systems, and application systems. Moving on, another way of help would be through legislation and regulation. Governments play a pivotal role in shaping sustainable phosphorus management. Enacting and enforcing regulations related to phosphorus use in agriculture, mining, and industry can significantly impact environmental outcomes. Guidelines on fertilizer application and phosphorus extraction, restrictions on certain phosphorus-containing compounds, and penalties for non-compliance create a regulatory framework that aligns human activities with ecological sustainability.
To conclude this video, we hope to have you leave knowing the what, the why, the who, and the how, so that you may be able to become aware of one of the many impacts that our actions have on the environment. This has been Group 3 of the Section A10. We thank you for watching this video, and goodbye.